Hi everyone, I want to welcome you to your first hybrid lecture. So each of these lectures you're going to view before coming to class. I'll give you some important information on the topics and I'll give you kind of a brief overview of it. And then after that what you'll have to do is you'll have to take a short quiz on the hybrid lecture. So here's what I recommend you do. I recommend you print out the PowerPoint slides and I recommend you use them as a guide. And as I kind of talk, you pay attention and take any extra notes that you might need. Okay, so today's lecture is going to be about methods for organizing and describing data. Specifically, I want to talk about something called a frequency table and frequency distribution. Okay, so here's where we've been. All right, if you remember our first class, we kind of talked a lot about how you see statistics in the real world. We did this interesting example about organ donation and talked about the 6-step process of statistics. And then we kind of got into the different types of data there were. There was qualitative and there were quantitative data. Now remember, qualitative data is kind of like a group or a characteristic that you might fit into. And quantitative data is a measurement of some type. Now remember, there are two types of quantitative data. All right, there's discrete data, which is counts, and there's continuous data, which is measurements of some type. Okay, so over the next week, here's what we're going to do. We're going to talk about describing data visually. So we're going to talk about two different types of graphs, specifically bar charts and histograms. All right, that's what this hybrid online video lecture will be about. And then when we come back to class, we're going to talk about describing data with numerical measures. We'll talk about measures of central tendency like the mean, median, and mode, and measures of dispersion, things like the range, variance, and standard deviation. All right, but let's go back and start talking about frequency. All right, so our ultimate goal is to be able to set up a frequency table and frequency distribution. So before we do that, we need three definitions. So the first is a class. Now a class is a category into which data is classified. I like to think of classes as groups for the data. All right, so like what group do you fit into? All right, so if you wanted to, you'll notice I'm adding something here. You might want to add that into your notes. So a class is just a group you belong into. All right, the frequency is the number of observations of the data set falling into each of those classes or groups. All right, I like to think of frequency as counts. All right, so it's how many are in each group. So it's like, oh, there's 5 in group A, 5 in group B, and so on. All right, the relative frequency is the class divided by the total number of observations in the data set. All right, what a relative frequency really is it's the percentage in each group, excuse me. So instead of saying, oh, there's 5 or 6 in group A, it would be something like there is 20% in group A, 20% in group B, and so on. All right, so the class is the group you fit into, frequency is count, and relative frequency is percentage. All right, so the first type of frequency table and frequency distribution we'll do is for qualitative data. And being that it's football season, I thought we'd do an example with football. All right, so here's the example. I ended up surveying 40 students in my class and I asked them if they were Jets or Giants fans. Given that we're near the New York City metro area, thought it was pretty appropriate. All right, so of the 40 students, 15 said they were Jets fans and 25 said they were Giants fans. So it looks like there's more Giants fans in the area. So what I want to do is I want to take this raw data, just these counts, and I want to put it into a nice viewable table. All right, and this is what's called a frequency table and a frequency distribution. All right, so here's what I do. You'll notice there are 3 columns and 3 rows. All right, the row headers here get the class or the groups, all right, and underneath that are my 2 groups, Jets or Giants fans. Great. The next column header is frequency, and that just gets the counts. All right, so there were 15 Jets fans, 25 Giants fans. And then over here you get the relative frequency. Now that's just the percentage that are each. All right, so to find the relative frequency, you take the individual frequency counts and divide it by the total number. So for example, there were 15 Jets fans. I divide that by 40. That gets me 0.375. So that's roughly 37.5%. You do the same thing with the Giants. Right? There are 25 Giants fans. Divide that by the total number of students surveyed, which is 40. And it looks like 0.625%, or excuse me, that is 0.625 or 62.5% are roughly Giants fans. So it looks like there's a lot more Giants fans in the area. All right, this table is a nice way to summarize the data. It's easy to digest, but we also might want to show it visually. Okay, so this is important. You showed this visually with what's called a bar chart. All right, qualitative data gets a bar chart. All right, so I did the following in Excel, so let me show you what they look like. You can see what I have here is I have a bar chart for the frequency, which is the counts. You can also show a bar chart for the relative frequency, and along the side here you have the percentages. All right, all you do to make a bar chart is along the horizontal or x-axis you put the two classes, so I have jets and giants. Along the vertical axis or the y-axis you can either put the frequencies, and you can put the counts however you want, or the relative frequencies, and then you just draw the bar charts up to the corresponding value. For example, there were 15 jets fans, so it goes up to 15. 25 giants fans goes up to here. Same over here with the relative frequency. My scale here along the side is the percentages. All right, so it looks like there were 37.5% were Jets fans, so I go up to 0.375. 25 divided by 40 was 0.625. So you take your Giants, you go up to 0.625. And this is just a visual representation of it. All right, so bar charts and frequency for qualitative data, all right, which just the groups you fit into and their corresponding counts, should be pretty easy. It should be pretty self-explanatory. All right. What's a little bit harder is when you have frequency distributions from continuous data. All right, now remember, continuous data may take on any value in an interval, all right, and these are our measurements. All right, so when you have data, that's some type of measurement. All right, so the example I want to do is suppose you have a manufacturer of installation randomly selects 20 winter days and records the daily high temperature. Maybe the manufacturer is just interested in knowing if they are installing enough insulation in houses, or on the same side if they've put too much in. So here's the deal. You have 20 different data values here, right? And they're all just 20. Some of them are the same, but there's 20 different ones. All right, so it's not like it's very easy where you have the groups predefined. All right, here it's just 20 simple 20 values. All right, so when you have continuous data, what you have to do is you have to take the data and put it into the groups that they are supposed to go into. Or let me put it another way. You get to define the groups that you want, all right, the classes, and then you get to count the values that go into them. All right, it might seem a little confusing, but it's actually pretty easy. And let me show you what we would do. All right, the first thing we're going to do is we're going to take those 20 temperatures and we're going to put them in order. All right, it looks like I got some temperatures that are in the teens, some that are in the 20s, some that are in the 30s, some that are in the 40s, and so on. Well, you know, when I think about temperature, when I talk to people, I'm like, oh, it's in the teens today, or it's in the 20s, or it's in the 30s. So here's what I'll do. I'll develop my classes to match that. So my first class will be all the temperatures between 10 and just under 20, so all the teens. The next class will be all the temperatures that are in the 20s, then in the 30s, then in the 40s, and so on, and then temperatures in the 50s. And then all I have to do now is I have to find the counts that are in each. So all the temperatures that are between 10 and 20, well, it looks like there's 3 of them. So that's its frequency or its count. All the temperatures between 20 and just under 30, well, it looks like there's 1, 2, 3, 4, 5. There's 6 of them. So that's my frequency for that class. And then so on. So the 30s, looks like there's 5 of them. The 40s, looks like there's 4 of them. In the 50s, it looks like there's 2 of them. From there, that's just my frequency column. What I want to now do is the relative frequency. So to get, for example, to get 0.15, I'm going to take 3 and divide it by 20. Now let me show you that. Let me load up my calculator. 3 divided by 20. So it's the class count divided by the total. That is 0.15. I'll go to the next one. 6 divided by 20. Look at that. That's my 0.30. And then so on. 5 divided by 20. 0.25. 4 divided by 20. 0.20. And then finally, 2 divided by 20. It looks like 0.10. Perfect. All right, so just like before, what we did is we took our raw data and we put it into a nice frequency table or frequency distribution. It just took all this raw 20 different data values and summed it up into a nice, neat table. All right, what we want to do next is we want to show this visually. All right, now this is important. If you want to show continuous data visually, you use a histogram. All right, so I'm going to write that here. Continuous data, histogram. All right, different from the qualitative data here. All right, that gets the bar chart. All right, so let me show you what a histogram looks like. All right, I'm going to set up my first quadrant. I'm going to do a frequency histogram. All right, and along the horizontal x-axis, you're going to get your classes. Now, you'll notice a big difference between the histogram and the bar chart here is that there's no spaces. Okay, please note that. No spaces between the groups. All right, so I started at 0. I went 0 to 10. Well, there were no groups in there. And you'll notice down here I have the number 5. All right, that's what's called the class midpoint. All right, so what number falls between 0 and 10? 5. Perfect. The next group right here are the values between 10 and just under 20. Well, there were 3 of them. I'll go back to that. 10 to 20. There were 3 of them. So the value that falls between 10 and 20 is the class midpoint. It's 15, so I mark that. And then I just draw a bar that goes up to the number 3. I go to my next class, 20 to 30. There were 6 of them. Well, 20 to 30, the value that falls right in between is 25. And I draw the bar right up to 6. And notice the bars are right next to each other. There's no space. They kind of build right off each other. Like the next one, 30 to 40. There were 5 of them. So between 30 and 40, the value that falls between that is 35. That's my marker. And I go up to 5. And I do so on for each group. All right, so the class midpoints here, sometimes that can be confusing. Those are just markers, but you could put the actual classes if you wanted to. But what's important about the histogram is that they build off each other. Right? Now, histograms are very, very important. Right? They tell us a lot about the distribution of the data. All right, so there's some questions you have when you set up the classes. All right, like how did I know to choose 10 to 20? All right, or how wide should they be? You know, my first one was 10 to 20, then 20 to 30. Do you notice how each interval is the same length, 10 degrees? All right, so there's 2 questions you should ask yourself. How wide should the intervals be, and how should the endpoints be? See, it's up to you, and a lot of times you can do this by trial or error, but a lot of times it's also pretty intuitive. You just don't want it to be too jagged or too blocky. All right, and I'll show you examples of that. You want to show the appropriate variation in the data. All right, now let me show you if I had chosen a class width of 4. All right, so this is too many blocks. And it looks like it's too jaggedy, so it looks like down, up, down, up, down. It looks like these could have been grouped together. These could have been grouped together. These together, and so on. All right, it's just too much is going on. This is just too few. If you look at these, this is a class width of 30. You know, and I look at this, and what does it tell me? It tells me it's a square. It doesn't tell me anything. It doesn't show me the distribution of the data. All right, histograms are going to be really important, all right, and they're going to come back to us quite a bit. So let me kind of explain to you what some common histograms look like and what they tell us. All right, this one we'll see a lot. All right, so histograms take on 5 very common shapes. When you have a histogram that looks like this is what we call normally distributed data. All right, this follows the bell curve. All right, if you look at this, what this means, let me give you an example in the real world. If you think about heights, average heights, or how tall adult males are. If you think of me, I'm about 5'10". I'm about the average height. Most people, all right, are going to be around the same height as me. Now, there's a few people, or there's people who are going to be taller. But people who are like 6'6" or 6'7", there's not as many of them, so it's less counts. Or there's adult males who are smaller than me, you know, 5'4", 5'2". Right? There's just not as many that are around my average height. So anything that looks like this is that bell curve normal distribution. All right, you could have things that are either right skewed, so right skew it looks like it has a tail to the right, or left skewed that has a tail to the left. So the way I like to think about it, it looks like a normal curve with a tail. Looks like a normal curve with a tail. An example of something that's right skewed might be average hour or TV. How much time people spend watching TV each night? You know, if you think about it, most of us probably spend around 1 or 2 hours. You know, some people no TV, some people a little bit more. But then there are a few people out there who watch a ton of television. You know, 8, 9, 10 hours a day. but there's not that many of them, so it has a tail that shoots out. An example I think of left skewed, maybe how many hours of television people watch, or not hours of television, excuse me, how many hours of sleep people got per night. You know, most of us get around 8, 9, there's a few people who get 10, 11, 12, but then there's some people who don't get much sleep per night at all. So, you know, 1, 2, 3, 4 hours, but there's just not as many of them. That's that tail to the left. All right, 2 others, finally. We have a bimodal, which like 2 normal distributions pushed together. All right, so when you see that, that's a bimodal distribution. All right, when you have multimodal, it looks like a bunch of jagged spikes. So it's down, up, down, up, down, up, down, up. All right. When you see the data that's classified this way, you can see what the distribution looks like. All right, so that'll be your first lecture, first hybrid lecture. I'll try to keep them under 15 minutes for you guys. If you need to, go back and review it. And when you get a chance, take the short quiz. All right, guys, I'll see you in class next time.